So, welcome Mahint, welcome Vishal, welcome Kranti, welcome to this session. We'll wait for participants to join and then we'll start the session in next few minutes. Hello, welcome everyone. Welcome to this session. Till the time we wait for participants to join, please go through our social media platforms. I've shared the link in the chat box. Hello everyone. Am I audible? Can someone please just confirm if I'm audible clearly? Hello everyone. Am I audible clearly? Okay, thank you, Abhishek. I thought I'm not audible clearly. So everyone, till the time we wait for the participants to join, please do go through our social media platforms and our meetup communities. I've shared the link in the chat box. Hello, everyone. Welcome to this session. We are waiting for participants to join. Till the time we wait for the participants to join, please go through our social media platforms, our meetup communities for regular. We update our webinars dates regularly on our social media platforms. So till then, go through our social media platforms, subscribe to our YouTube channel, follow us on Instagram, and don't go anywhere. We will start the session in next few minutes. Hello, everyone. Hello, Smith, sir. Am I audible clearly?
Yes, you're audible.
Okay, thank you so much. So, we'll start with the session. Hello and I welcome everyone. I'm Shubh Parmar, your host for today's webinar. My team and I are here to make sure you have a seamless and engaging experience. If you have any questions or have any need any assistance, please feel free to use the chat window. We are here to help. So the topic for today is Microsoft Fabric for financial solutions. This webinar is hosted by the ATC community, a hub for enthusiasts passionate about cloud technologies, AI, machine learning, IoT, open source development, and DevOps. Uh, so today's event is sponsored by Synergetics. Synergetics is a leading edge learning solutions provider in India, offering specialized training and consulting services. We empower businesses and professionals to thrive in today's fast evolving tech landscape by delivering transformative learning experiences. Our core focus is on enabling digital transformation through innovative skilling programs, advisory services, and end to end implementation support. From modernizing IT frameworks to mastering emerging technologies like AI, cloud computing, and DevOps, Synergetics is committed to equipping you with the tools and knowledge to succeed. These are the learning solutions which are offered by Synergetics, which is persona based onboarding, onboarding add on, certification add on, reskilling, emerging technology training, certification hackathon, cloud adoption, latest technology training, sales, pre sales training, practice playbook, and architecting. This is the Microsoft certification skilling journey. The journey begins with the fundamental certification. Then it progresses to advanced role based certification and finally to expert level certifications. We run communities on Meetup. This is the emerging technology community. Anyone who are eager to learn about technological knowledge can join this community on Meetup. We have multiple communities in Pune, Nagpur, Gujarat, and Indore. Those who are interested to join this community, please log into the Meetup app and gain your knowledge for free. We are thrilled to have Smith Shah as today's speaker. He's a certified Microsoft trainer and a consultant at Synergetics. He brings a wealth of knowledge and experience in AI and cloud technologies. The agenda for this webinar is Introduction to Microsoft Fabric, Data Integration and Pipelines, Lake Houses and Real-Time Analytics, Compliance, Governance and Security, Power BI for Financial Insights, uh, you have to follow the code of conduct, which will create a respectful environment for all the participants. Participants, please note you are not allowed to take screenshot of the presentation and cannot do screen recording. I would like to take a moment to share information about the certification workshops we conduct at Synergetics. These webinars you have been attending are designed to give you a brief overview and summary of the full course content. However, the actual certification training programs for these courses run over 4 days, and we are currently offering them at a special discounted rate exclusively for webinar attendees. On my screen, you can see the list of in demand certification courses we are currently focusing on. For more details or to register, I will share contact of one of my colleague, Mr. Vivek Balasundaram. You can connect with him for more details regarding this courses. All right, everyone, it's time for a quick quiz to make our session a little more interactive and fun. So, we will have 5 questions lined up. Each one will test your knowledge of today's topic. So, don't worry, it's all about learning. So, think of this as a chance to check how much you have picked up already. Okay, so you can see the first question. What just drop your answers in the chat box. Okay, what is the main benefit of using Microsoft Fabric in financial solutions? Okay, I can see already everyone is answering. Okay, everyone quickly drop your answers. Okay, so yes, the answer is B. Everyone is correct. Streamlining data pipelines and analytics is the right answer. We jump to the next question. Which Microsoft Fabric component is most useful for managing large scale financial data storage? Quickly drop your answers in the chat box, guys. Yes, C is the right answer for this question. Lake houses. We jump to the next question now. How does Power BI add value when integrated with Microsoft Fabric for Finance? Quickly drop your answers, guys. That's correct. B is the right answer. Creates interactive financial reports and visualizations. We jump to the next question now. In financial services, compliance and governance in Microsoft Fabric help with what? Quickly drop your answers, guys. Yes, that's correct. A is the right answer. Regulatory requirements and data security. We quickly jump to the next question. This is the last question. Which of the following is a real world use case of Microsoft Fabric in finance? Quickly drop your answers, guys. This is the last question. So the correct answer is B. Sending bulk emails is the right answer. Well done, everyone. Uh, so yeah, do follow us on our social media platforms to get relevant updates on upcoming webinars, workshops, and certification trainings we do. Thank you so much, everyone, for listening to me. Now we'll hand over the mic to a speaker. Smith, so you can take over from here.
Yes, thanks, Shop. So, good afternoon to each and every one of you, and welcome to the session on Microsoft Fabric. My name is Smith Shah, and I will be your mentor for today's session. I'm a Microsoft certified trainer. On top of that, I'm a Azure certified data scientist, a Azure certified AI engineer, as well as a Azure certified data engineer. and I've been conducting trainings in the data science and AI field since the last 7 to 8 years for multiple international as well as domestic clients, including LTM Entry, Capgemini, Accenture, and many, many more. So that was just a brief introduction about me. Now let's start with our main agenda for today's session. So guys, today's session will span for a duration of 2 hours. Okay. And today we are going to work with a data set on finance domain. And using that data set, we will see how to create models. In particular, we'll create a machine learning model using Fabric. Okay. So we'll see how to create models using Fabric. Before using models, before using models on our data, we'll have to analyze that data. So using Fabric, how it becomes easy for you to analyze data, just like how you can create charts in Power BI. In a similar way, you can create charts in Fabric as well. So we'll be seeing that. But our main agenda for today's session is to work with a data set on finance domain. Okay. And we will see how to create a machine learning model on that data using Microsoft Fabric. So let's first understand what is machine learning. Okay. Everybody of you might have a doubt. Okay. Especially if you are new to machine learning. What is machine learning? So guys, machine learning is nothing but a set of tools that is used to get inferences through predictions. By inference, we mean insights. Okay. So basically machine learning is nothing but a set of tools that is used to get inferences through predictions, or in other words, it is used to get insights through predictions. Now you might ask me that, Smith, how do we do that? How do we get inferences through predictions? So guys, we do that by using something called a machine learning model. Now, what is a machine learning model? It's a very popular term being used in the market nowadays, right? But what is it? What is a machine learning model? So guys, I will show you the definition of a machine learning model. The definition might look complex at first, but don't worry, I will simplify it for you later. So what is a machine learning model? So guys, a machine learning model is nothing but a statistical representation of a real world process. As I mentioned earlier, the definition might look complex to you, but don't worry, I'll simplify it. And in order to simplify it, I will take help of an example. Let's suppose I have information about some of the houses in my locality, and I'm showing you that information on the screen. Let's assume we have information about area of the house in square feet, and I also have information about the price of the house. Now let's suppose the first house that I surveyed had an area of 100 square feet and the price of the house was 1 crore. The second house that I surveyed had an area of 200 square feet and the price of the house was 2 crore. The third house that I surveyed had an area of 300 square feet and the price of the house was 3 crore. Now I have a question for each and every one of you. Let's suppose we come across a fourth house. The area of that house is 350 square feet. According to you guys, what would be the price of this house? Can anyone give me their prediction? According to you guys, what do you guys predict could be the price of this house? You can mention your predictions in the chat. So one student has rightly mentioned 3.5 crore, right? So that's your prediction, 3.5 crore. And that's the correct prediction, right? Even Imtiaz, Kirtiman, Barsha have mentioned that prediction, that according to you guys think the price of the house would be somewhere around 3.5 crores. And you guys are right. But in order to arrive at this prediction, you guys use some mathematics in your brain. You guys use some statistics in your brain, right? That's exactly what a machine learning model also does. A machine learning model also tries to use statistics or tries to use mathematics to simulate what would happen in the real world. Okay, to simulate what would happen in the real world. Fine. So let's go ahead and let's understand some of the important notes that we need to remember before creating a machine learning model. Okay, so guys, there are two notes that we need to remember before creating a machine learning model. Note number one is that for creating a machine learning model, we need some data, and that data needs to have some rows and some columns. Okay, then you might ask me that, Smith, we have heard that we can create models on image data as well. And image data is not in the form of rows and columns. You guys are right. We can create models on image data. And although image data is not originally in the form of rows and columns, but when we try to create model on that image data has to be converted into row and column format. Then only we'll be able to create a machine learning model on it. Okay. So note number one is that for creating a machine learning model, you need some data, and that data needs to have some rows and some columns. Note number two is that there are only two useful type of columns in your data. First useful type of column is called a feature column. Second useful type of column in your data is called a target column. What's the difference between the two? Well, a feature column is a column that helps me to predict, whereas a target column is a column that I want to predict. Let's understand the difference between a feature column and a target column with help of an example. Let's suppose I have data of some of the houses in my country, and here is that data shown to you on your screen. Now, I want to understand in this data, which will be my feature column, which will be my target column. Remember the difference between a feature and a target column. The difference is that a feature column is a column that helps me to predict, whereas a target column is a column that I want to predict. So if I want to predict on price, then price will be which type of column, guys? Remember, a feature column is a column that helps you to predict, whereas a target column is a column that you want to predict. So if you want to predict on price, then price will be which type of column? As Shanti Prakash has rightly mentioned in the chat, it will be a target column, right? A target column is a column that helps us to predict. So since we want to predict on price column will be our target column. And since square feet and city help me to predict on price, they will be called my feature columns. Okay. So a feature column is a column that helps me to predict, whereas a target column is a column that I want to predict. Now, let's go ahead and let's look at the different type of machine learning models we can create. There are many types. Today we'll only talk about two main types because more than 95% of the work done in the machine learning industry is done on these two types only. Okay. So for today, we'll only focus on these two types. The first type of model that we'll be talking about is called a supervised learning model. The second type of model that we'll be talking about is called a unsupervised learning model. What's the difference between the two? Well, a supervised learning model is a model wherein the data that I'm using, that data has feature columns and target column both. Whereas unsupervised learning model is a model wherein the data that I'm using, in that data, we only have feature columns, we do not have target column. Okay, at the time of demonstration, it will become more clear to you what's the difference between supervised learning model and unsupervised learning model. For now, just remember that supervised learning model is a model wherein the data that I'm using has feature columns and target columns both, whereas unsupervised learning model is a model wherein the data that I'm using only has feature columns, it doesn't have target column. Now, supervised learning models are further divided into two types. First is called classification model. Second is called regression model. What's the difference between the two? And before I talk about the difference, I'll just mute all the participants so that you don't hear any background noise. Now, let's proceed with our learning. So guys, as I was trying to say that in supervised learning model, there are two type of supervised learning models that you can create. First is called classification model. Second is called regression model. What's the difference between a classification model and a regression model? So guys, remember that in a classification model, the target column has finite set of possibilities. So if your target column has finite set of possibilities, then the model that you will be creating on that data will be called a classification model. On the other hand, if you are creating a model on data wherein the target column has infinite set of possibilities, then your model will be called a regression model. Okay. So if you are creating model on data wherein the target column has finite set of possibilities, your model will be called a classification model. If you are creating model on data wherein your target column has infinite set of possibilities, then your model will be called a regression model. Let's understand the difference between classification model and regression model with help of an example. Let's suppose I have a target column with me called dice roll, wherein what I'm doing is I'm playing a game of dice with my friends, and whatever value I get after rolling the dice, that value I'm storing in this column. Let's suppose when I first roll the dice, I get the value 4. Again, when I roll the dice, I get the value 6. Again, when I roll the dice, I get the value 1. Again, when I roll the dice, I get the value 6, and so on. Now let's assume that this dice roll column is my target column. Okay. Now my question to you is, in this target column, how many different possibilities do we have? Or let me put the question in more simple words. When I roll a dice, how many different possibilities do I have? Can anyone answer that? When we roll a dice, how many possible values can we get?
6.
6, right? As you guys have rightly mentioned, we have 6 possibilities. When we roll a dice, we can either get the value 1 or 2 or 3 or 4 or 5 or 6. We only have these 6 possibilities. So that means you are saying that when we roll a dice, we have 6 possibilities, or we have finite set of possibilities. If dice roll column is your target column, that would mean that your target column has finite set of possibilities. And if your target column has finite set of possibilities, your model will be called a classification model. Let's take one more example. Let's suppose we have a target column with us called gender, wherein I'm storing the gender value of every participant in this meeting. Let's suppose the first participant that entered this meeting had a gender of male. The next participant that entered this meeting had a gender of female. The third participant that entered this meeting had a gender of male, and so on. Now let's assume that this gender column is my target column. In that case, my target column has how many possibilities? Here you will say that my target column has only 2 possibilities, right? Either my target column value will be equal to male or it will be equal to female. That means you are saying that in your target column you have finite set of possibilities. And if your target column has finite set of possibilities, your model will be called a classification model. Let's take one more example. Let's suppose I have a target column with me called stock price, wherein I'm storing the price of the stock after every day. Let's suppose on the first day, the price of the stock was 99.3 rupees. On the next day, it was 100.475 rupees. On the third day, it was 98.46 rupees, and so on. Now, if stock price column is my target column, then in this target column, do we have finite set of possibilities or infinite set of possibilities, guys? What do you guys think?
Infinite.
Finite or infinite? So as you guys have rightly mentioned, we have infinite set of possibilities, right? As Kirtiman and Praveen have mentioned, we have infinite set of possibilities. And if my target column has infinite set of possibilities, in that scenario, my model will be called a regression model. With this, I hope basics of machine learning is clear to all. Is it clear to everyone, guys? Any doubt up till now in basics of machine learning? I hope basics was clear. Praveen has raised his hand. Any doubt, Praveen?
No, no, sorry. I just
Okay.
want to say yes.
Yes, okay, perfect. So with this, we have understood basics of machine learning. Now let's see how to create a machine learning model. Okay, we know the definition of machine learning model, right? That a machine learning model is nothing but a statistical representation of a real world process, right? A machine learning model is nothing but a statistical representation of a real world process. In other words, we'll use some statistical steps to simulate a real world process. Those statistical steps, I can call it as statistical algorithm. So basically, I will use some statistical algorithm, or in other words, some mathematical algorithm to simulate a real world process. Now it depends upon you whether you want to create a statistical algorithm from scratch or whether you want to use some statistical algorithms already available in the market. In today's session, I will show you one statistical algorithm already available in the market. The name of that statistical algorithm is called decision tree classifier. Like that, there are many statistical algorithms. Okay. But today we'll talk about one statistical algorithm called decision tree classifier. Now you might ask me that Smith, this algorithm is used to create which type of machine learning model? Supervised learning model or unsupervised learning model? So guys, remember that it's used to create a supervised learning model. That means it will only work only if your data has feature columns and target columns both. Then you might ask me that Smith, within supervised, there are two type of models, classification and regression. So this algorithm called decision tree classifier is used to create which type of model, classification model or regression model? Remember that it's used to create a classification model. That means it will only work only if your target column has finite set of possibilities. Okay, fine. So let's go ahead and let's see how this algorithm works. Before that, I need to teach you a concept called decision tree. So in decision tree classifier algorithm, we will be building a decision tree for classification purposes. So let's first understand what is a decision tree. Okay. What is a decision tree? In order to understand what is a decision tree, I will take help of an example. So guys, let's assume that you are a government official, and your job is to check whether a person should be given a driving license or should not be given a driving license. Okay. So as per the government rules, the rules are, okay, as per the government rules, only those people that have a driving score greater than 60 and have age greater than 18, okay, or I should say only those people whose driving score is greater than or equal to 60 and have age greater than or equal to 18, greater than or equal to 18, can get the license. Okay. Let's suppose these are the government rules that only those people who have a driving score greater than or equal to 60 and have age greater than or equal to 18 can get the license. So now let's assume that you are a government official. Let me take help of one student. Let's assume, Praveen, that you are the government official who will check whether a person should be given driving license or should not be given driving license. Okay. Now, Praveen, please help me out. Let's suppose you are a government official. So what will you check first? Let's suppose I came to you that, Praveen, please give me my license. So as per rules, what will you check first?
I'll first check if the age of the applicant is 18 or more.
Correct. So if the age is less than 18, then what will you do?
I'll straight away reject the application.
Correct. You will not give license. Perfect. And or as you rightly mentioned, you will reject the application. You will reject the license. Okay. On the other hand, if age is not less than 18, okay. So if age was less than 18, as you rightly mentioned, you will reject the license application. But if this condition does not satisfy, if age is not less than 18, then what will you do
I'll
as
check
per
his
rules?
score. I'll
Hmm.
check his driving score on the scale of whatever it is there. If it is more than or equal to 60,
Okay, correct. And if the driving score is less than 60, then what will you do?
I'll again reject
Correct.
license.
Right. You will reject the license application. And if this condition doesn't satisfy, if the person's driving score is not less than 60, then what will you do?
I'll approve his application.
Correct. Okay. You will approve the license application. Okay. So here, can I say, Praveen, that the diagram that we created on the screen is nothing but we have created a tree-like structure that helps us to make decisions, correct? Right? The diagram that we have created in blue
Yes.
color over here is nothing but a tree-like structure that helps us to make decisions. So a tree-like structure that helps us to make decisions is called a decision tree. So basically over here with help of Praveen, we basically created a decision tree. But for us humans, it was very easy to create a decision tree. But how will the computer create such a decision tree? Let's understand the mathematics behind the scenes. Okay. For us humans, it was very easy to create this decision tree. But how will the computer create it? Let's understand. So let's suppose I have some data with me. Okay. And before that, guys, before I show you how the computer creates a decision tree, I want to cover some important terminologies. And that terminology is called nodes. Okay, what is it called? Nodes. So what is a node? A node is nothing but a rectangular shaped object that you see in this decision tree. So for example, this is a node, this is a node, this is a node, this is a node, this is a node. So total we have 5 nodes in my decision tree currently. Okay. So what is a node? It's nothing but a rectangular shaped object in your decision tree. Okay. Now there are three type of nodes in your decision tree. First is called root node. Second is called internal node. And third is called leaf node. Okay. Third is called leaf node. So there are three type of nodes in a decision tree. First is called root node. Second is called internal node. Third is called leaf node. Now, what is the difference between each of these three type of nodes? Let's go ahead and let's understand that. So I will try to explain the different type of nodes. As I mentioned, in any decision tree, there will always be three type of nodes. First type of node is called root node. Second type is called internal node. Third type is called leaf node. Let's understand the difference between these three type of nodes over here. So let's first start by understanding what is a root node. Okay, let's first start by understanding what is a root node. So guys, a root node is nothing but the topmost node of the tree. Okay, what is a root node? A root node is nothing but the topmost node of the tree. And in any decision tree, will only have one root node. Okay, in any decision tree you take that is created in the world, you will only have one root node. Okay, so root node is nothing but the topmost node of the tree. The second type of node was called internal node. Internal nodes are those nodes that have arrows pointing to them and also have arrows pointing away from them. I repeat, internal nodes are those nodes that have arrows pointing to them and also have arrows pointing away from them. Okay. Then the third and last type of node is called a leaf node. What are leaf nodes? Leaf nodes are those nodes that have arrows pointing to them but do not have arrows pointing away from them. Okay. So I repeat, guys, there are three type of nodes in any decision tree. The first type of node is called root node. Root node is the topmost node of the tree. The second type of node is called internal node. Internal nodes are those nodes that have arrows pointing to them and also have arrows pointing away from them. Okay. The third and last type of node is called a leaf node. So what is a leaf node? A leaf node is that node that has arrows pointing to it, but does not have arrows pointing away from it. Okay. So these are the three type of nodes in any decision tree. So guys, you tell me in the decision tree that we have created over here on the screen, as you observe, we have created a decision tree on the screen in blue color. In this decision tree, how many root node do you see? How many? One, right? As Imtiaz has rightly mentioned, one root node. And I guess Imtiaz, you're talking about this node as the root node. Perfect. Now, similarly, guys, in this decision tree, how many internal nodes do you see? Remember, internal nodes are those nodes that have arrows pointing to them and also have arrows pointing away from them. One, right? So only one internal node, guys. This node has arrows pointing to it and also has arrows pointing away from it. You can see that. Okay, so we only have one internal node, right? What about the third and last type of node, which is leaf node? Leaf nodes are those nodes that have arrows pointing to them, but do not have arrows pointing away from them. And as Ashutosh
Right.
has rightly mentioned, we have three leaf nodes, right? And I guess Ashutosh is talking about these three as the leaf nodes. All right. So remember, in any decision tree, you will always have three type of nodes. First is root node, which is the topmost node of the tree. Second is internal node. Internal nodes are those nodes that have arrows pointing to them and also have arrows pointing away from them. Third and last type of node is called leaf node. Leaf nodes are those nodes that have arrows pointing to them but do not have arrows pointing away from them. So guys, for us humans, it was very easy to create this decision tree, right? In fact, with help of Praveen, we created this decision tree. But let's understand how a computer will create such a decision tree. Let's understand that. So let's suppose we want to create a model using decision tree classifier algorithm. If we want to create a model, we will need some data, right? Let's suppose I have data having three columns. The first column is called age, second column is called driving score, and third column is called eligibility for driving license. Let's assume that out of these three columns, the first two columns are my feature columns, and the last column is my target column. Okay. Now, we have our data and the data is shown to you on the screen. Let's understand with this data, how will we proceed ahead? Now, I have a question for you. Using this data, I want to create a decision tree, right? So guys, the first node that I need to start off is called which type of node, guys?
Root node.
Root node, right? As Praveen has rightly mentioned, it will be called my root node. Now, Praveen, can I say in my root node, I will have to find out the best condition to put in my root node based on which the root node will be splitted into two parts. Correct? Agreed, guys, right? That over here from
Yes.
my root node, we'll have to find the best condition to put in my root node so that the root node can be splitted into two parts. Now, my job is to find the best condition to put in my root node. Let's see how will I find the best condition. So in order to understand that, I have a question for you. The question is, let's assume that you are a head of a company and you want to hire one software engineer. Now, in order to hire one software engineer, you have two approaches. First is you can interview all these software engineers in the world, all the software engineers in the world. Second approach is you can interview only the shortlisted software engineers. So guys, which approach will you prefer? Interview all the software engineers or interview only the shortlisted software engineers? As the head of a company, which approach will you like? Second approach, right? As Ashutosh and Praveen have rightly mentioned, second approach, right? Similarly, guys, if I want to find the best condition to put in my root node, will I test all the conditions or will I test only the shortlisted conditions? You tell me which approach will be better. Testing all conditions or testing only the shortlisted conditions? Shortlisted ones, correct, as Kirtiman has rightly mentioned, as Ashutosh has rightly mentioned. Well, it's better to test only the shortlisted conditions. But then you will have a question. That Smith, fine, we know testing only the shortlisted conditions will be more efficient. But how do we shortlist conditions? Let's understand that. So guys, remember that conditions are shortlisted using feature column values. Okay. Conditions are shortlisted using feature column values. And here guys, how many feature column do I have in my data? Two feature columns. So using values of these two feature columns, conditions will be shortlisted. Let's see how. So guys, first step to shortlist conditions is to sort the values in that feature column. Okay. Sort the values. Let's see. So I will take my first feature column and I will sort the values. Let's sort the values over here. Second step is to take the average of consecutive feature column values. So average of 17 and 19 will be 18. So that means my first shortlisted condition will be age less than 18. Similarly, the average of the next two consecutive feature column values is 20. So my next shortlisted condition will be age less than 20. Then the average of next two consecutive feature column values is 22. So my next shortlisted condition will be age less than 22. Any more consecutive feature column values left for which we have not taken average? No. So that's it. We'll stop over here. So from age column, how many conditions were we able to shortlist? Three conditions. Remember the rule of thumb that if a feature column has n values, then n minus 1 conditions will be shortlisted out of it. And since the age column had 4 values, that is why 4 minus 1, that means 3 conditions were shortlisted out of it. Okay. So this is the rule of thumb that you can remember. All right. So from age column, I have shortlisted conditions. Now from driving score feature column also, I will shortlist conditions. Let's do it. You know the first step to shortlist conditions. First step is to sort the feature column values. So let's sort the feature column values. Then the next step, take average of consecutive feature column values. Average of 30 and 50 will be 40. So the next shortlisted condition will be driving score less than 40. Then the average of next two consecutive feature column values will be 60. So the next shortlisted condition will be driving score less than 60. Then the average of next two consecutive feature column values is 80. So the next shortlisted condition will be driving score less than 80. Okay. Fine. So now any further consecutive values left in driving score column for which I have not taken average? No. So that's it. I'll stop over here. So from driving score feature column, how many conditions were shortlisted? 3 conditions. You know the rule of thumb that if a feature column has n values, then n minus conditions will be shortlisted out of it. And since the driving score column has 4 values, that is why 4 minus 1, that means 3 conditions will be shortlisted out of it. Okay. Any further feature columns left? No. That's it. I only had age as my feature column and driving score as my feature column. No further feature columns left. So guys, in total, we can declare that I have shortlisted 6 conditions in total. How many conditions? 6 conditions. 3 conditions from first feature column, 3 conditions from second feature column. All right. Now that I have shortlisted the conditions, I need to test them out, right? I need to test them out. That which condition is the best one? That out of these 6 shortlisted conditions, which condition is the best one? Let's see. So guys, what is the purpose of these conditions? The purpose of these conditions is to split the node into 2 parts, right? So if I will apply this condition in a node, then using the condition, I should be able to split the node into 2 parts. That's the purpose of this condition, right? Helping to split the node into 2 parts. So let's see how each of the condition is helping to split the node into 2 parts. Okay, and whichever condition is splitting it in the best manner, that condition will declare as the best one. Let's see how we'll declare. Okay, but first we'll start with our first shortlisted condition, age less than 18. So guys, there will be some rows that satisfy the condition and there will be some rows that do not satisfy the condition. Okay. So guys, in my data, how many rows satisfy the condition age less than 18? In my data, how many rows satisfy the condition age less than 18? Can you tell me? In my data, have a look at the data at the top. In my data, how many rows satisfy the condition age less than 18? One, right? As Swarna, Praveen, Shanti Prakash, Samuel have mentioned, we have only one row, this row. So guys, among the rows that satisfy the condition age less than 18, how many times target value of yes is occurring? Among the rows that satisfy the condition age less than 18, how many times target value of yes is occurring? I repeat my question. Among the rows that satisfy the condition age less than 18, how many times target value of yes is occurring? 0 times, right? As Shanti Prakash has rightly mentioned, among the rows that satisfy the condition age less than 18, target value of yes is occurring 0 times. Okay, so over here I will just write yes equal to 0. Then guys, similarly, among the rows that satisfy the condition age less than 18, how many times target value of no is occurring? Among the rows that satisfy the condition age less than 18, how many times target value of no is occurring? As you guys have rightly mentioned, no is occurring 1 time. Perfect. Similarly, guys, now let's come to those rows that do not satisfy the condition age less than 18. So there are 3 rows that do not satisfy the condition age less than 18. Among those 3 rows, how many times target value of yes is occurring? Among those 3 rows, how many times target value of yes is occurring? 1 time, right? And among those 3 rows that do not satisfy the condition age less than 18, how many times target value of no is occurring? How many times target value of no is occurring? 2 times, right? So over here I will just write 2. So guys, this is how the first shortlisted condition is splitting the node into 2 parts. Up till your understanding? Is everyone understanding up till now, guys? Clear? Right? Okay, I can see thumbs up, so I'm assuming it's clear. But if you have any doubt, you can ask. Okay, so this is how the first condition is splitting the node into 2 parts. Similarly, guys, okay, just like how the first condition splits the node into 2 parts, you can see the same diagram is shown in the PPT as well, right? This is how the first condition splits the node into 2 parts. In a similar way, we will see how the second shortlisted condition splits the node into 2 parts. In a similar way, we will see how the third shortlisted condition splits the node into 2 parts. In a similar way, we will see how the fourth shortlisted condition splits the node into 2 parts. And in a similar way, we'll see how the fifth and sixth shortlisted condition split the node into 2 parts. Now what I need to do is I need to test these shortlisted conditions so that I can figure out that which is the best condition out of these 6 shortlisted conditions. Just like when you are a head of company and when you want to hire a software engineer, your first process will be to shortlist the software engineers. Once the software engineers are shortlisted, then you will test them so that you can figure out of the 6 software engineers or out of the different number of software engineers, which is the one best software engineer, right? You will test them. Similarly, guys, here I have found out these 6 shortlisted conditions. Now I will test these 6 shortlisted conditions to figure out which is the best one. Okay. Now, how will we do a test? In order to do a test, we will apply a formula. Which formula? There are multiple formulas that you can apply. Popularly, everybody applies this formula called Gini impurity. There are other formulas as well, but mostly people use Gini impurity formula to test. Okay. Mostly people use Gini impurity formula to test. Let me explain the Gini impurity formula. And to explain, I will take help of whiteboard, but it seems the whiteboard is taking a longer time to load. Let me refresh again and see. Okay, fine. Now the whiteboard is loading. So now let me explain the formula of Gini impurity. The formula is 1 minus summation of probability of obtaining target value square. Target value square. Okay, let's understand. Now I have a question for all of you. In my data, have a look at my target column. How many unique values do you see? How many unique values do you see over here? Unique values. The values is 4, but what about unique? Only 2 unique values, right? Yes and no. Correct? Yes and no. These are the only 2 unique values. Okay, so I'll mention that. So now my Gini impurity formula will become 1 minus probability of obtaining yes square, 1 minus probability of obtaining yes square plus probability of obtaining no square plus probability of obtaining no square. Okay. So this is how we will apply Gini impurity for our data. Okay. The general Gini impurity formula, I have mentioned it at the top in blue color, but depending upon your data, the implementation of Gini impurity will change. Currently in my data, there are only 2 unique target column values, yes and no. And you can see depending on that, my implementation of Gini impurity formula changed. So this is the formula that I will use to test the shortlisted conditions and see which is the best condition out of those. Okay, so this is the formula that we'll use to test the shortlisted conditions. Let's do it. So let's start with the first shortlisted condition and let's apply Gini impurity over here. So guys, what I will do is first I will apply Gini impurity on the left child node. Then I will apply Gini impurity on the right child node. After that, I will calculate overall impurity of the condition. I repeat, in order to calculate overall impurity of the condition, I will first calculate Gini impurity of the left child node. Then I will calculate Gini impurity of the right child node. After that, I will calculate overall impurity of the condition. Okay, let's do it. You know Gini impurity formula, which is 1 minus probability of obtaining yes square plus probability of obtaining no square. So guys, let's start with the left child node. Let's calculate Gini impurity on the left child node. So 1 minus probability of yes square. What is probability of yes in the left child node? In the left child node, how many rows are occurring? Total 1 rows, right? Why? Because in the left child node, I have those rows that satisfy the condition age less than 18. And in my data, only 1 row satisfies the condition age less than 18. Right? And out of that 1 row, how many times target value of yes is occurring? Out of that 1 row, how many times target value of yes is occurring? 0 times. In the left child node, there is total one row, and out of that one row, how many times target value of yes is occurring? 0 times. So probability of yes in the left child node will be 0 divided by 1. And then I will square it as per Gini impurity formula. Similarly, what will be the probability of no in the left child node? In the left child node, I have total one row, and out of that one row, how many times target value of no is occurring? One time. So probability of no will be 1 divided by 1. And then I will square it as per Gini impurity formula. If I solve this, I'll get a value equal to 0. So Gini impurity of the left child node is equal to 0. Okay. Gini impurity of left child node is equal to 0. Guys, similarly, let's calculate Gini impurity of the right child node using the same formula. 1 minus probability of yes square plus probability of no square. Okay. In the right child node, how many rows do I have? I have those rows that do not satisfy the condition age less than 18. So I have a total of 3 rows. Okay. Out of those 3 rows, how many times target value of yes is occurring? One time. So probability of yes in the right child node will be 1 divided by 3. Okay. And then I will square it as per Gini impurity formula. Plus probability of obtaining no in the right child node. In the right child node, I have a total of 3 rows. Out of those 3 rows, how many times target value of no is occurring? 2 times. So probability of no will be 2 divided by 3. And then I will square it as per Gini impurity formula, exactly as Praveen has mentioned. Okay, fine. And you can solve this equation and you will end up with some Gini impurity value. And you will see in these slides also same exact thing will happen. Okay, same calculation, just like we had done. So what I have done is I have calculated Gini impurity of the left child node. I have calculated Gini impurity of the right child node. Now I will calculate overall impurity of the condition. How to do that? How to do that? Any suggestions, guys? What to do? What to do? So let's assume that in a class you have 2 students. Okay, those students have got some marks. Now you want to calculate the overall marks of the entire class. For that, what will you do? Which formula you will apply? Average, right? As Praveen has mentioned, average. Perfect. Correct, Praveen. We'll apply average. And you're correct. Okay. But let's suppose, guys, that we are talking about a big school wherein in one division, okay, I don't know in your states what is it called, but in my state it's called a division. Okay, in my board that I studied, like we had divisions, division A, division B, division C, like that. So let's suppose in division A you have one student. In division B you have 3 students, and I want to calculate the overall marks obtained in the school for that particular standard. Will I apply average? Well, normal average will not work. Why? Because the number of students in both the divisions is different. So instead of normal average, I will have to apply something called weighted average. Okay. Similarly, guys, here if you have a look, the number of rows in both the nodes is not the same. In the left node, I have 1 row. In the right node, I have 3 rows. Since the number of rows in both the nodes is not the same, I cannot apply normal average. Instead, I will have to apply weighted average. But if the number of rows in both the nodes were the same, okay, let's suppose in the left node I had 2 rows, in the right node also I had 2 rows. If number of rows in both the nodes were the same, then I could just apply normal average, like Praveen has mentioned. Okay, but here the number of rows in both the nodes is not the same, so I cannot use normal average. Instead, I will have to apply weighted average. Okay, let's see how to calculate that. I'll apply weighted average. So in the left child node, I have a total, how many rows? 1 row. Okay, and total in my data, how many rows I had? 4. So out of 4 rows, okay, out of 4 rows, 1 row occurs in the left child node. 1 row comes in the left child node. Okay, that means weight of the left child node is 1 divided by 4. So weight multiplied by the impurity value plus the weight of right child node is what? In the right child node, I have 3 rows. In my data, total had 4 rows. Out of 4 rows in the right child node, 3 rows are occurring. So weight of right child node will be 3 divided by 4 multiplied by impurity of the right child node, which is 0.45. If I solve this equation, basically this is our equation of weighted average. So basically using weighted average, I am arriving at overall impurity of my condition. Okay. Up till here, guys, is everyone understanding that how did I arrive at overall impurity of my first shortlisted condition? Overall impurity of my first shortlisted condition is 0.34. Okay. In a similar way, guys, we will calculate overall impurity of the second shortlisted condition. In a similar way, we'll calculate overall impurity of the third shortlisted condition. In a similar way, we'll calculate overall impurity of the fourth shortlisted condition. In a similar way, we'll calculate overall impurity of fifth shortlisted condition. And in a similar way, we'll calculate overall impurity of sixth shortlisted condition. Now, we have calculated impurity for all these six shortlisted conditions. Out of these six shortlisted conditions, we want to find out the best condition, one best condition. How will we do it? Let's suppose you have six glasses of water in front of you. Each glass of water has some impurity in it, but you need to drink one glass of water. Which one will you drink? The one having least impurity, right? If you have six glasses of water in front of you, each glass of water has some impurity in it, and I tell you that no, you have to choose one out of these six, you will choose the one having the least impurity. Similarly, guys, here I have six shortlisted conditions shown to me. I want to choose the best condition out of these six. Which one will I choose? The one having the least impurity. You tell me, guys, that which condition has the least impurity? First one, second one, third one, fourth one, fifth one, or sixth one? Which one has the least impurity? Which condition has least impurity? So Praveen is saying second and fifth condition have least impurity and there is a tie, right? Even Prashant is saying that, even Shanti Prakash is saying that there is a tie between second and fifth condition. Whenever there is a tie, computer will try to sort out that tie by choosing any one out of these two conditions randomly. Okay. The system will try to solve that tie by choosing any one out of these two conditions randomly. So let's suppose there is a tie between second and fifth condition. Let's suppose the system randomly chose fifth condition as the best condition to put in my root node. Okay. So that fifth condition is driving score less than 60. Let's suppose that condition is now put in our root node. Fine. So in my root node, I have found out the best condition. Now, guys, can I say I need to figure out which will be the best condition in these nodes so that even these nodes can be split further into two parts each? Correct or not? Yes or no, guys? See, I figured out the best condition to put in my root node. This done. But now I will have to figure out that which is the best condition to put in these child nodes so that even these child nodes can be splitted further into small parts and the tree can grow further. Correct? So now the question is, how do I know whether to split a node further or to not split a node further? The decision making is very simple, guys. Okay. And how is that decision made, that whether should I split the node further into two parts or should I not split a node further? Okay. The decision is made by using impurity value. So if the impurity value of a node is equal to 0, that means that node is perfect and there is no need to split it further. Okay. If the impurity of a node is 0, that means the node is perfect and there is no need to split it further. But if the impurity is not equal to 0, that means the node is not perfect and you can go ahead and split it further into two parts. Okay. So let's investigate, guys, that should I split this node into two parts? So we'll calculate impurity. We know Gini impurity formula. 1 minus probability of yes square plus probability of no square. If I solve this equation, I will get a value equal to 0. And since the impurity value is equal to 0, will I split this node further or will I not split it further? What will I do? Will I split or not split? What will we do? As Samuel mentions that if the impurity of a node is 0, that means the node is perfect and there is no need to split further. Even Swarna says that if a impurity of a node is 0, that means the node is perfect and there is no need to split it. So guys, the left child node is perfect node and there is no need to split it further. Okay. What about the node on the right hand side. Let's investigate whether we should split this node further or not. For that, we'll calculate Gini impurity. You know Gini impurity formula, 1 minus probability of yes square, 1 minus probability of yes square plus probability of no square. And if I solve this equation, I'll get a value equal to 0.5. So since the impurity of a node is not 0, what will I do? Will I split further or will I not split? What will I do? As Samuel mentions, we will split further, right? See, when to not split? Only if the impurity is 0. But if the impurity is not 0, then you can go ahead and split that node. So now I will have to figure out, Samuel, which is the best condition to put in this right hand side node. Correct, Samuel? I will have to figure out which is the best condition to put in the right hand side node, right? Okay. How to do that? Again, process will remain the same. First, shortlist conditions, then test those shortlisted conditions to see which is the best condition. Okay, let's see. So guys, in the right hand side node, I have those rows that do not satisfy the condition driving score less than 60. And guys, how many such rows do I have in my data that do not satisfy the condition driving score less than 60? Do not satisfy the condition driving score less than 60. How many such rows do I have in my data? Two, right? As Santi Prakash rightly mentions, two. And I guess Santi Prakash, you are talking about these two rows, right? The ones that I have highlighted over here. These two rows. Correct? So now Shanti Prakash will only focus on these two rows. Okay, because in the right hand side node, only these two rows are present. All right. And let's see which is the best condition to put in the right hand side node. We'll repeat the process to find the best condition. First is shortlist the conditions. So Shanti Prakash, you must you would remember that rule of thumb, right, buddy? That if a feature column has n values, then how many conditions will be shortlisted out of it? N minus 1, right? As Shanti Prakash has mentioned, n minus 1. So similarly, Shanti Prakash, now my age feature column has two values. That means 2 minus 1. That means one condition will be shortlisted out of it. And which will be that one condition? Which will be that one condition from age feature column? Age less than 18, right? As Ashutosh has rightly mentioned, age less than 18. Similarly, Ashutosh, what will be the shortlisted condition from driving score feature column? From driving score feature column. Driving score less than 80, right? Driving score less than 80. So in total, I will shortlist two conditions. These are the only two conditions that I'll be able to shortlist over here. Okay, fine. So same process that we followed earlier to shortlist conditions, same process we are following over here. Okay, same exact process. Now what we will do is we will test these shortlisted conditions using Gini impurity. So let's test the first shortlisted condition using Gini impurity. And you can see in order to arrive at Gini impurity value for this particular condition, the left hand child node and the left hand side node and right hand side node had same number of rows. Okay, one row each. That's why in order to arrive at overall impurity of the condition, I just applied normal average instead of applying weighted average. Okay. Anyways, fine. So over here, I found out overall impurity of the first shortlisted condition. Then I will find out overall impurity of the second shortlisted condition. And guys, you tell me which is the best one over here. You will say that there is a tie. And we know, right? When there is a tie, what happens? The system tries to solve that tie by choosing any one condition randomly. Okay, so this time maybe it can select the first condition randomly as the best condition. Okay, the first one is age less than 18. Let's suppose it chose that condition age less than 18 as the best one, and that condition it has now inserted in this node, age less than 18. Okay, now let's proceed ahead. So guys, if you guys remember, the left hand side node we had decided to not split, right? Because its impurity was 0. Now let's investigate whether these nodes will be splitted further or not. For that, we'll calculate their impurities. Okay, so what is the impurity of this highlighted node? If I calculate Gini impurity, you will see that it will turn out to be 0, guys. Okay, it will turn out to be 0. Since the impurity is 0, this node will not split further. Similarly, let's calculate impurity of the right hand side node. Should we split this node further? For that, we'll calculate impurity. And here when I calculate impurity, it will turn out to be 0. Okay, that means even the right hand side node I will not split. So guys, is there any node left now to split? Any node left? Is there any node left? No, right? So that's it. We'll stop the tree making process over here. And now, Ashutosh, can I say that these last nodes that I'm deciding to not split will be called my leaf nodes, buddy? Can I say that? That the last nodes that I'm deciding to not split will be called my leaf nodes, right? And remember that in these leaf nodes, through leaf nodes, you get prediction made by the algorithm. Okay. So let's see how to arrive at this prediction. Okay. So you guys tell me, so Kirtiman, you tell me, buddy, that in the first leaf node, which target column value is occurring most number of times? In the first leaf node, which target column value is occurring most number of times? Yes or no? Which one is occurring most number of times? No, right? So where I'll just mention target equal to no. Okay, in the second leaf node, which target column value is is occurring more number of times? Again, target equal to no is occurring more number of times. So I'll mention that one over here. Okay, in the in the third leaf node, which target column value is occurring more number of times? Target column value equal to yes is occurring more number of times. So that I'll mention over here. And same thing will be mentioned in the slides as well. So now going forward, okay, if a person comes to us whose driving score is 50 and age is 30, let's use this decision tree to make a decision. Okay, so as per the decision tree, first it will check, is the driving score less than 60? Yes, it is less than 60. In that case, it will decide that the person is not eligible for driving license. Okay, and like that you can use the decision tree to make more decisions over here. So basically, guys, this is how the computer creates the decision tree. Earlier we had created a decision tree manually. If you guys remember, we had created one decision tree manually, right? And I guess I had used the help of Praveen for that, and using help of Praveen we had manually created a decision tree. Have a look. This decision tree and the one created by computer looks almost the same. Now guys, in this algorithm, yes, it works well, but there is a big issue. Okay, what is that issue? The issue is that if there is a tie between two conditions, how does it solve that tie? How does it solve it? By choosing any one condition randomly, right? Like if there is a tie between first and second condition, it will choose any one out of these two randomly. And in our case, the first condition was chosen randomly. Fine, so it worked. But what if it chooses the second condition as the best condition? Then can I say, guys, that my maybe my decision tree that would have been made would not be that much accurate in making decisions? Possible that while choosing a condition randomly, it might choose a condition that is not that good. Possible or not, guys? Yes.
Yes.
Right? And there's a major problem of decision tree classifier algorithm. So like that, every algorithm will have some or the other problem. Okay. No algorithm is foolproof. There will be some drawbacks. There will be some advantages. Okay. So there's one disadvantage of decision tree classifier, that if there is a tie, it tries to solve that tie by choosing any condition randomly. And when it tries to choose any condition randomly, there is a possibility that it might choose a condition that is not that great. Okay, it might choose a wrong condition as the best one. That's possible. Okay, and because of that, the decision tree that is made is not that accurate. Fine. So there's a problem with decision tree classifier algorithm. Like that, every algorithm will have some of the other problems. No algorithm is foolproof. Okay. Anyways, with this, we have understood the theory. So guys, did the theory of this algorithm make sense? If theory is clear, then we'll see the implementation part now with Microsoft Fabric. Is the theory clear? Yes. Okay. If there is any doubt, you can ask me. Okay. But
Is it?
I'm assuming that theory is clear. Yes, Santi Prakash.
Yeah, we have taken an example of two features and one target.
Hmm.
So, is it possible to say that for each feature you should have a decision tree?
Not necessarily. You mean for each, are you saying that each feature column should occur at least once in decision tree?
No, I'm not saying that. What I'm saying is, see, um, if a human would have gone through that, so
Hmm.
basically over here, what we are saying is the condition is age should be greater than 18 and driving score should be greater than or equal to 60 for a person to get license, right? So
Hmm.
basically, we are checking for two conditions for giving license.
Hmm.
So
Right.
now over here, is it possible to say that each for each feature we should have a decision tree, like for
No,
each?
no. See, this is one decision tree, right, buddy? This is one single decision tree, correct?
Yes.
Irrespective of the number of feature columns you have, whether you have 200 feature columns, 2000 feature columns, you will have one decision tree only.
Okay.
Okay. Process
Okay.
will remain the same.
Honey, because then, like as you were explaining, we could have ended up with the conditions of driving score only.
It is possible that if there is a tie, it randomly chooses a bad condition. That possibility is there.
Hmm.
But your question was that if I have more number of feature columns, will I have to create more decision trees? No, it's just that my decision tree will get lengthier. It will get bigger.
Okay.
Okay. But decision tree will always be one, buddy. So irrespective of the number of feature columns that we have, one decision tree will be enough for us. It's just that depending upon the number of feature columns you have, your decision tree could get bigger. Currently, my decision tree is smaller because I had very few feature columns. But if I had more feature columns, maybe my decision tree could have been more bigger. Okay, it could have been bigger. Okay. But that was your doubt, buddy. Is your doubt clear?
Yeah.
Yes. Okay. Perfect.
Yes.
Now let's go
So
ahead.
I have
Sumit,
a doubt.
I have
Yeah. Yep. Can I
Hmm.
can I go on? Yes.
yes,
Yes.
go ahead.
So in the decision tree, you mentioned that there were two features, but you selected age as the root node. So is there any condition like how do we select the root node? It could have been the driving
It could have
thing.
been.
Yes.
If
So
there
will
is
it?
a tie, if
Hmm?
there is a tie, it will randomly choose any one condition out of it, right?
No. Will it change my feature or will it change my percentage or impurity percentage if the root node becomes different?
See, if in your root node you are putting a different condition, okay, let's
Huh?
understand that. We talked about the disadvantage of dysentery classifier. What was the disadvantage? That if there is a tie, then how
Hmm.
does it solve that tie? By choosing any one condition
Any random.
randomly. So, right?
Yes.
So when we
Yes.
were trying to find the best condition in our root node, we saw
Hmm.
that there is a tie between second and fifth. So it
Hmm.
randomly chose anyone between second and fifth.
Okay.
Correct?
So whichever feature we choose in the root node, that will not make a difference in my decision. That is what you are saying, right? The
No, no.
randomness will be there.
If it chooses randomly, okay,
Huh?
there is a possibility that it might choose a condition that is not that good.
Hmm.
Okay, here, irrespective of the condition that I would have chosen, it would have been fine for me. But what about, let's suppose, internal node? Okay,
Hmm.
irrespective of the node that we are working on. Let's suppose internal node. For my internal node, I was finding which will be the best condition to put. There is a tie. And
Hmm.
what did I say? Not to solve that tie, computer will choose any one condition randomly. And my computer randomly chose first condition as the best condition.
Hmm. Hmm.
But what if second condition was chosen? Then can I say that would have made my decision tree less accurate? Because the second condition is not that good, right? So it is
Yeah.
possible, Barsha, that your dysentery classifier, when there is a tie between two conditions, to solve that tie, since it chooses a condition randomly, it might choose a condition that is not that good. And because of that, the end decision that is made is not that accurate. It's possible. And that's why we said that this is a disadvantage of dysentery classifier,
Got it.
right?
Hmm.
Right. So like this, none of the algorithms are foolproof. Okay, there's a problem with dysentery classifier. Like that, any algorithm you study, there will be some or the other disadvantage in it. So none of the algorithms are foolproof. Okay, then I guess someone else was also asking a doubt. Yes, any other doubt?
It was the exact same question only. How to
Same.
choose the root uh, uh, root cell?
Huh. So in root node or internal node, process to choose the best condition is the same. That shortlist the conditions, test those shortlisted conditions, and whichever condition has least impurity, choose that condition as the best one, irrespective of whether you're working in root node or internal node. Okay. And as we mentioned that, okay, although the process remains the same, but in the process, there is a catch that we select the condition having least impurity. What if multiple conditions are having the least impurity and there is a tie? And to solve that tie, computer chooses any one out of those conditions randomly. And there's a possibility that the computer randomly chooses a bad condition, or I should say not that good condition. Okay. And if it chooses a condition that is not that good in your dysentery, then your dysentery's decisions will also be not that good. So your overall accuracy will go down then. Okay, so that's possible. Okay, so there's a drawback of dysentery classifier. If there are any other doubts, you can ask. Swarna says, what about the leaf nodes? Swarna, leaf nodes are leading to the decision. Okay, so currently have a look. We have our 3 leaf nodes, right, Swarna? 3 leaf nodes. They are helping me to make a decision. They are helping me to predict the target column value, basically. They are helping me to predict the target column value. So for example, let's suppose I'm being asked to make a prediction that if the driving score is equal to 70 and if the age is equal to 9, should we give the license? So what we would do is, so basically we are being asked that whether the person is eligible for driving license or not. And your eligibility for driving license is my target column, right? So I'm being asked to predict my target column value. I'm being asked to predict my target column value. Let's see how we'll do that by using this descent tree. So first we'll check, is the descent is the driving score less than 60? No, it's not less than 60. Okay, so what will we do? Since it's not less than 60, we'll follow this path. Okay, then we'll check, is the age less than 18? Yes, the age is less than 18, so we'll follow this path. And in that scenario, we are arriving at a decision that no, the person is not eligible for driving license. And that's what that is the prediction made by this algorithm, that no, the person is not eligible for driving license. So Swarna, what is the role of leaf nodes? Role of leaf nodes is to make a decision, or in other words, arrive at a target column value, predict the target column value. Okay, or in simple words, make a decision. Technically, we would say that it helps to predict the target column value. So here, which target column value was predicted? A target column value of no was predicted. Got it, Swarna? Okay. If there is any doubt, you can ask. Okay, fine. Now let's go ahead and let's see the implementation, guys. Okay. So guys, this is the Fabric user interface. Okay. And now in order to create a model, what should we do? So guys, first of all, you will have to create a workspace in your Fabric tool. Okay, so let's create a workspace. Okay, so you can think of it as a folder for your project. Okay, so basically, let's suppose we are creating a project. Here, this project will help me to create a machine learning model. So let's suppose I have given a name to that workspace. Okay, given a name to that project that will create a machine learning model. Okay, let's create a workspace, and you'll be able to see your workspaces by clicking on the workspaces button. Okay, fine. Now what we'll do is we will go ahead and we'll try to upload our data. Now, guys, if you use other tools apart from Fabric, if you use a tool like Azure Machine Learning, through which you can create machine learning models, with that tool, you will observe that Azure Machine Learning helps you to create models, but it does not store the data within itself. So in order to store data, you had to integrate it with Azure Storage Service, which stored data for you, right? So you had to take help of a separate tool, because Azure machine learning tool does not help you to store data. Yes, it helps you to create models, but for creating model, we need data, and Azure machine learning does not store data within itself. But guys, with Fabric, okay, with Fabric, you can not only create machine learning models, but you can also store data within it. Okay. And that facility is available through a concept called Lakehouse. Okay, that facility is available through a concept called Lakehouse. And using Lakehouse, you can store your big data files over here. This is not available in other tools. If you choose a tool like Azure Machine Learning to create machine learning models, Azure Machine Learning does not store data within itself. Same with Synapse. If you choose a tool like Azure Synapse to create machine learning models, in Azure Synapse, you cannot store data within itself. Okay. So guys, with the other tools that is usually you know implemented in enterprise level scenarios, those tools do not help you to store data within itself. Yes, they would help you to create machine learning models, but they will not help you to store data. Whereas Fabric gives you a one-stop solution for all the things. Okay, so you can store data within itself, you can use the data for your task, one-stop solution for all things. Okay, so let's use this concept of lakehouse to upload our data. We'll give a name to this lakehouse. We will say data collection. Okay. And in this lakehouse, we will go ahead and upload our data file. And what we'll do is we'll get that data file from Kaggle. So let's work with a data file from Kaggle, which is based on finance domain. Okay. It is called credit risk dataset. Okay. So I'll get this data file from Kaggle. I'll go ahead and download it. But for downloading, I will need to sign in. So let me sign in first. After the sign in process is complete, then I'll move forward. All right. Now let me go ahead and let me download this data. I'll click on download button here so that my data is downloaded. Now this data file that I have downloaded, I will just go ahead and first of all unzip it. Let me unzip. Okay, here I have my data file. I'll just go ahead and copy it and paste it in a separate folder called datasets folder. This is where I usually store all my datasets. Fine. All right. So you can see I have a dataset on finance domain and it is related to loans. Okay, it is related to loans. So you have different columns. Let me explain those columns. So for example, the first column is called person age. So age of the person. Second column is called person income. Third column is called person home ownership. That means is the person living in a rented house or a mortgaged house, or is he or she living in their own house. Okay. Then the employment length. I guess this would be in months or something. What does it say? What does it say? Employment length in years. Okay, fine. Employment length in years. Then the next column is loan intent. Okay, loan intent. That means that what is the intent of the loan? Did the person take the loan for education purposes or medical purposes, or what was the intent? Okay. Then I will have to go ahead and talk about this next column called loan grade. What does this loan grade mean? Okay, some grading is given over here, A, B, C, D. Okay, unsure what that is. I guess if it's a higher loan, then a grade of A is assigned, or maybe fine, doesn't matter. We have this column over here, which we'll use. Okay, so we have a loan grade column. Okay, after loan grade, we have a column called loan amount. Okay, then loan interest rate, loan status. That means the whether the person defaulted on the loan. Defaulted on the loan means did not pay the loan. Okay, non-default means the person paid back the loan. All right, then I have loan percent income. That means how much um, percentage of his income was the loan taken. I guess something like that. Let me see that column over here. Okay, loan percent income. Okay, so here it says the for this person the income is around 0.3%. That means 0.3. That means I guess 13% of the income of his sorry, his income is 13% of the loan. Okay, that's what it is saying. Okay, his income is 13% of the loan, and so on. Like that loan percent income column is there. Then some other columns are also there where credit history length. Okay, some historical default. What does that historical default do? Let me see those columns as well. What does that column do? Historical default. Let's see the values. Okay, that means previously whether the person defaulted earlier or not. Okay, fine. All right, so we have this data. We'll be creating a machine learning model on this data using an algorithm called decision tree classifier on the Fabric tool. All right, let's see. So first of all, I will just go ahead and upload my files. So here there is an option to upload my files. Let's do that. I'll go ahead and upload my files over here. Let's go ahead and upload. So this file that I just downloaded from Kaggle, we'll go ahead and upload that. Okay. And after uploading, I'll just go ahead and refresh this. Now, hopefully our uploaded file should be shown to us. Okay, fine. We can see the uploaded file now. Now what I'll do is I'll open a notebook file wherein I will write some code to create a model. So let me create a new notebook file. I'll go ahead and create a new notebook over here. Let me create it. And now I will say, please load the data in this notebook file. Okay, so I had some data with me, okay, which was in the form of files. So I will say, please load the data from these files in my notebook using pandas library. Okay, or you can choose any other library as well. So you can see automatically code for that is written. So no need for me to write code from scratch. All right, so over here, my data will be displayed to me. And once my data is displayed, we'll see how to use that data to create a model. Remember, to create a supervised learning model, there are a few steps that you need to follow. So step number one is that your data should be clean. Okay, your data should be clean. Okay, in simple words, your data should not have any spelling mistakes. It should not have any missing values. Okay, it should not have any missing values. Your data should not have any spelling mistakes, and so on.
So, does Microsoft Fabric handle null values? They can handle.
Automatically, it does not. Okay, we will have to take help of the Power BI integration. Just like in Power BI, for example, there are ready-made functions that can do that, right? Even here, there are ready-made functions that can do that. Okay. But we are
So,
not going to work with those ready-made functions. We are going to do everything manually.
okay.
Okay. But yes, there are ready-made functions that can do that data cleaning for you. You just have to click on the specific buttons, and using that you can do data cleaning. But with that, what happens is control is lost. Okay, so to have more control over your data cleaning, I always prefer the with code approach. But yes, the without code approach is also available if that's your doubt. Okay. Yes. So this is your first step. Okay. Now, second step, guys, is to extract the features and targets separately. Okay. Extract the features and targets separately. Your third step is to make sure that features should be of numeric nature. Features should be of numeric nature. Your fourth step is to make sure that you split the data into two parts, training and testing. Then your fifth step is to train the model on the training data set. Okay, train the model on the training data set. And your sixth and last step is to test the model on the testing data set. Test the model on the testing data set. Let's go ahead and let's follow these steps over here. Okay, so we'll go ahead and we'll follow these steps. Let's see. So our first step, okay, where did that cell go? Okay, fine, no worries. I'll write that cell again. There were 6 steps. First step is that data should be clean. Second step is to extract the features and targets separately. Okay, fine. I guess that cell is now coming. Okay, it's now shown to me. All right. So no need for me to write those steps again. Fine. So guys, step number 1 is that data should be clean. It should not have any missing values, any spelling mistakes. So over here, let's check for missing values. You can see we do have some missing values. So in my data, there are a total of 32,000 rows, out of which 895 rows in the employment length column is missing. Okay, so now in order to deal with missing values, you have two options. Okay, two main options. First is you can either remove the missing values or you can replace the missing values. In removing, you have two sub options. Either you can remove the rows having missing values or you can remove the columns having missing values. Now remember guys, that leaves us with three options in total. Removing rows having missing values, removing columns having missing values, and replacing missing values. Now remember that none of these three options are ideal. Okay, they are bad in their own way. But we have to choose an option that is least bad for our current scenario. Okay, each of these three options are bad in their own way. We have to choose an option that is least bad for our current scenario. So for employee length column, you can see that there are some missing values. Okay, so how would you solve them? Whether you would you want to remove rows? Maybe you can. Whether should you remove columns? I don't think I should remove that column, as this could be a very good feature column. By the way, in this data, what will be my target column? Let's suppose I want to build a model that will predict whether a person will give back the loan or whether a person will not give back the loan. A similar model is available in all the banks as well. So when you submit a loan application, your loan application is then submitted to the model. The model then decides that, okay, what is your what is the risk to give loan to you? Okay, that whether you will give back the loan or whether you will not give back the loan. Fine. So let's create a similar model that will predict whether a person will give back the loan or whether a person will not give back the loan. All right. Fine. So over here, I feel that maybe in this column, since there are missing values, I can remove rows having missing values, maybe. Okay, so I'll put question mark over here. Remove columns, definitely not. Replace the missing values, maybe. Now over here, each of these three options are bad in their own right. Okay, without talking about the guidelines that we need to follow, there are many guidelines, but without talking about that, in general, just remember that we'll choose an option that is least bad for our current scenario. Okay, we'll choose an option that is least bad for a current scenario. So I feel over here replacing is least bad for me. So I will try to replace the missing values in this column, okay, by something. So what I'll do is I'll replace the missing values in this column by the average value of that column. Okay, it depends upon you which aggregation formula you want to use. There are guidelines. I will not talk more about that here due to limited time. Okay, but there are general guidelines that can guide you. Okay, to understand that in which scenario, which option to choose. Remember, in general, that each of these three options are bad in their own right, but we have to choose the option that is least bad. Okay, for our current scenario. All right, so for this column, I feel replacing is the least bad option. So let me go ahead and let me replace the missing values in this column by the mean of that column. Okay, similarly, guys, okay, after this, what I'll do is once this replacing is done, I will save the new values in this same column only. All right, now after this, at least in the employment length column, I will not have missing values. I only have missing values now in loan interest rate column. Even here, I feel replacing the missing values in this column will be more better. Okay, so let me go ahead and let me do that. In this column also, I'll try to replace the missing values. There are general guidelines. We'll not talk about that here. But in general, just remember that there are three options to deal with missing values. You have to choose the option that is least bad for that current scenario. Okay, and that decision has to be made by you. All right. There are certain rule of thumbs. We'll not talk about that here since that's not our main goal. Our main goal is to create a model over here. So first step done. Okay, I have uh, dealt with missing values. There are no spelling mistakes in my data as well. I know this data. There are no spelling mistakes. Now, step number two. Step number two is to extract features and target. So guys, over here, my target column will be this column called loan status. That means whether the person will give back the loan or whether the person will not give back the loan. Okay. One means the person gave back the loan, whereas a value of 0 means the person will not give back. Okay. And guys, if you want to go ahead and plot this data, you can go ahead and make a chart of this data as well. Okay, that in total, you can see over here it has some suggested chart. But if you want to build your own chart, you can go ahead and build that as well. Okay, just like you do in Power BI. But fine. Over here, this was just to show you that yes, data visualization is possible. So here it's better to do data visualization. I will not do that. Okay, due to lack of time. But remember, before using the data, it's better to visualize the data to understand the nature of that data. Okay, so that you can take your decisions ahead wisely. All right, anyways, I'll not do that data visualization over here, but remember for your knowledge that just like in Power BI, how you can create data visualization, even here we can do that. All right, first step is done. Second step, extract my features and target. So here guys, this loan status column will be my target column, and all the other columns apart from target will be my potential feature columns. Okay, all the other columns apart from target will be my potential feature columns. Will be my potential feature columns. Okay, so all the other columns apart from target are your potential feature columns. Let's have a look at our potential feature columns. Let's see if there is any column that is not worthy to become a feature. I don't think so. I feel all of these columns are worthy to become features. So let me keep all of these columns. Now, the third step is to make sure that features should be of numeric nature. Okay, so let's see if the features are of numeric nature or not. If you observe, okay, if you observe, you will be able to see, okay, if you observe, you will be able to see that there are some feature columns which are non-numeric. Okay, so for example, home ownership column, loan intent column, loan grade column, the default on file column, all of these columns are non-numeric. You can even see their values. They are non-numeric values, right? So if there we have feature values in non-numeric, if we have features which have non-numeric values, those non-numeric values have to be converted into numeric values. Now there are many ways to do that. I will show you one way. There are many different ways. Okay. We'll not dive into in which scenario to choose which way, but I will show you one way over here today. Okay. So let me explain one approach to convert the non-numeric feature column values into numeric feature column values. And that technique is called one-hot encoding technique. Let's see how that works. So let's suppose I have a non-numeric feature column called head of countries, wherein I'm storing the names of head of the countries that I've visited. Let's suppose the first country that I visited, the head of that country was Mr. Trump. The next country that I visited, head of that country at that time was Mr. Trudeau. The next country that I came next, head of that country was Mr. Modi. The next country that I went, head of that country was Mr. Trump, and so on. Let's suppose. Okay. So now you can see this column has non-numeric values. How will you convert non-numeric values into numeric values? You through one-hot encoding. Let's see. First step of one-hot encoding is to find out the total number of unique values in your non-numeric column. Can you tell me in this non-numeric column, how many unique values will we see? Do you see how many unique values? Three, right? As Praveen mentions. And those three values are Trump, Trudeau, and Modi. So depending upon the number of unique values, we'll create that many columns. Okay, so if there are three unique values, we'll create three columns. Now let's fill in the column values. In the first row, is there a value of Trump? Yes, that's why in the Trump column, I'll mention 1. Then in the first row, is there a value called Trudeau? No, so I will mention value of 0 in Trudeau column. In the first row, is there a value called Modi? No, so I will mention value of 0 in the Modi column. Going to the next row now. In the second row, do I have value for Trump? No, so I'll mention value of 0 in the second row. In the second row, do I have value for Trudeau? Yes, that's why I'll mention a value of 1. In the second row, do I have value of Modi? No, so I'll mention a value of 0. Like that, I'll go ahead. In the third row, do I have value for Trump? No. So in Trump column, I'll mention 0. In the third row, do I have value for Trudeau? No. So in Trudeau column, I'll mention 0. In the third row, do I have value for Modi? Yes. So in Modi column, I'll put 1. Like that, I'll do it for the fourth row as well. And you can see with this, what I have done is the non-numeric values have been converted into numeric values. Yes, in the process, we ended up with more columns than what we had before, but this is just how one-hot encoding works. There are other techniques as well apart from one-hot encoding. Okay, we'll not talk about others due to lack of time, but remember one-hot encoding is one such technique, and this technique will apply in our scenario. Okay, so let's apply. So over here, I will say that I want to apply one-hot encoding on my features. And which columns of our features? Let me mention their names. So first is home ownership column, right? I want to apply one-hot encoding on that. Then we have loan intent column. I will apply one-hot encoding on that. We have loan grade column. We'll apply one-hot encoding on that. Then this default on file column. Okay, so we'll apply one-hot encoding on that. Fine. And with this, what we have done is we are trying to apply one-hot encoding on our non-numeric column values. In the process, we'll end up with more columns than what we have before, but that's fine. That's how one-hot encoding works. Now, guys, have a look. In the new version of pandas, instead of 0 and 1, it will write false and true. Okay, you can see, but doesn't matter. Behind the scenes, false will be treated as 0, true will be treated as 1. Okay, in the earlier version of pandas, it used to write 0 and 1 only, but in new version of pandas, instead of 0 and 1, it writes so here false and true. Anyway, it doesn't matter for us. False will be treated as 0, true will be treated as 1. All right, with this, what we have done is we have made sure that if at all there are any non-numeric feature column values, we convert them into numeric feature column values. Fine. With this, third step done. Now, fourth step. Fourth step is to make sure that features should be divided into two parts, training and testing, right? Step 4. Let me copy step 4. I'm not able to copy it properly. Step number 4. Split the data into two parts, training and testing. Okay, let's see how to do that. In order to do it, I'll need help of sklearn library. So from sklearn, okay, 1 second. I'll just write the code properly over here. Let me write the code properly. Okay, so from sklearn folder, there is a file called model selection. From that file, I will try to import this function called train test split. Now I'll go ahead and call that function. Okay, first I'll pass my features. After that, I'll pass my target. And then I'll mention the ratio in which I want to divide the data into training and testing. So over here, I'll say, let's suppose 20% of rows will go into training, the remaining 20% of rows I want in testing, the remaining 80% I want in training. It depends upon you which ratio you want to set. Usually people prefer 80-20 split, meaning 80% of rows in training, 20% in testing. You can follow 70-30 as well. It's up to you. Fine. Now remember, the rows will be selected in training and testing randomly. So it's not like always the first few rows will go in training data set, or the last few rows will go in training data set. No, the selection of rows will be random. Now, because of that random selection, there are a few problems that will occur, but fine. Today we'll not discuss those. Okay. But fine, this is okay for us, and we'll be able to split our data into two parts, training and testing. First, our features will be splitted into two parts. We'll get feature train and feature test. Then our target will be splitted into two parts. We'll get target train and target test. Okay, with this, step number 4 done. Now, step number 5. What is step number 5? Train the model on the training data set, right? Train the model on the training data set. Let's go ahead and let's copy this step. Train the model on the training data set. Let's see. I'll mention this step here. So in order to train model, I will need a algorithm. So either I can develop my own statistical algorithm, or I can use an algorithm already available in the market. Let me use a algorithm already available in the market called decision tree classifier algorithm. So in order to implement it, I'll need help of a class which I will import. From sklearn folder, there is a file called tree. From that file, I will try to import this class called decision tree classifier. Okay, after importing, I'll go ahead and call that class. So it's like waking up the algorithm that please wake up. We are going to use you for training. Okay, and once the algorithm is woken up, using the algorithm will train the model on the training data set. So guys, out of the four things that I got in train test split, which things are part of training data set? Feature train and target train are part of training data set. So we'll just mention that over here. Feature train and target train. And our model will be trained. Now remember guys, over here, whatever computation takes place, right? Whenever I'm running code in Fabric, in order to do computation, you do not have to set up compute. Okay, this is not the case with other tools, guys. For example, in Azure ML tool, you have to set up the compute first before running the code to create a model. In Azure Databricks tool, you have to set up the compute. But over here, you can see I did not have to set up any compute. That's second advantage. Okay, so Fabric gives you a one-stop solution for all the things. It gives you a facility to store your data inside. Okay, also to do task using that data, whatever compute is needed, it sets up the compute automatically for you. You don't have to set up the compute. Okay, fine. So a lot of things, it makes it easier for us. All right. With this code, what will happen is the model will be trained on the training data set. Now remember, I'm training it using dysentery classifier algorithm, which is a basic algorithm. There are much better algorithms than this. If we use better algorithms, our accuracy of the model will be even better. Okay, and also there are some best practices which I have avoided in this current code. If I had followed those best practices, my accuracy would have been even better. We'll not talk about those best practices, not in the agenda of today's session. Okay, and apart from that, we don't have time today as well. Okay, but remember over here, our model will be trained. I will show you performance of the model, but don't expect too much. Why? Because we have applied a very basic algorithm. There are much better algorithms than this, and also I have not followed I have not followed the best practices. So I'm just simply creating the model just to show you that okay, a model can be created. Okay, a simple model I'm creating. Fine. So fifth step done. Now last step, guys. Okay, which is test the model on the testing data set. Test the model on the testing data set. Okay, let's see how to do it. So for that, I will use the score method. Now, guys, which things are part of my testing data set? Out of the four things that I got in train test split, feature test and target test are part of my testing data set. So let me pass that over here. Feature test and target test. Okay, that's it. We'll get an accuracy score. Remember, accuracy will always be between 0 to 1. The more the accuracy is closer to 1, the better the model is. Okay, but don't expect too much accuracy. Okay, here we get accuracy of 0.9. For a model to be acceptable, you would say we would want accuracy at least greater than 0.7. That means at least in percentage terms greater than 70% accuracy. In order to convert this accuracy value to percentage, just multiply by 100. So here we can say we are getting around 89% accuracy. Okay. There are many things I can do to make these things better. Okay. I can follow some best practices. My accuracy would have been even better. I can apply even better algorithm as compared to dysentery. My accuracy with that better algorithm will be more better. But over here, this was just to show you that yes, a model can be created. Okay, so it says on the testing data set, it made predictions and it was around 98, 89% accurate in those predictions. Okay, so let's suppose there are 100 rows in the testing data set. It made predictions on all those 100 rows, and out of 100 rows, correct predictions were made on 89 rows. That's why it gives a accuracy of 0.89. That means 89%. Okay. Now, once the model is created, you can use it to make predictions. Okay. So just pass your some feature column values. So what I will do is, let me take the first feature column value. Okay. You can pass your own data as well. Doesn't matter. But here I will just take the first row of data. You can create your own custom data. It's not necessary that your data has to be only from the rows that you gave to the model. No, it can be some other data as well. But if I try to create my own data over here, what might happen is I would be spending a lot of time. So to avoid that, I'm just taking this data which is already available to me. So I want the first row. So let me properly write the code to get the first row. All right, let me properly write the code. So I'll say give me the first row of data and all the columns. So this is the data that I want to predict on. Okay, perfect. Now what I'll do is I'll ask the model to make predictions. So it will try to predict whether this person will give the loan or will not give the loan. You can see this person has an age of 22 years, has income of 59,000. Okay, loan amount is so and so, like that. Like that, you can predict on any row. Okay, if you want to predict on any row, you can take that. Okay. Guys, remember that here I'm just taking data from the rows that I already provided to the model. It's not necessary to do that. It's better that you create your own custom data. Okay. But anyways, due to lack of time, I'm just mentioning, I'm just taking the rows from the data that I already have with me. All right. And now let me ask the model to predict on this data, and it will try to predict whether this person will give the loan or whether this person will not give the loan. Target value of 1 means the person will give back the loan, right? And I guess that's the data, right? Let me see. In loan status, what does it say? No, target value of 1 means default. Okay. That means the person will not give the loan. Okay. And 0 means null default. Okay. So non-default means the person will give the loan. All right. Let's see what our model thinks. Okay. Let's see what our model thinks over here. A model gives a target value of 0. Target value of 0 means the person will not default. So that means it's safe to give that person the loan. Okay. So over here, this was just a glimpse to show you the capabilities of Fabric. That first, it gives you a one-stop solution for your task. So let's suppose if you want to create model, there are many tools, right? Azure ML tool, Databricks tool, Azure Synapse, but none of those tools have capability to store data inside of it. Okay. Whereas Fabric gives you a one-stop solution for that. Okay. You might say Databricks Smith has capability, but remember that Databricks has capability to only store small data files. If you pass big data files, it will not be able to store it. Okay, so basically the disadvantage with any tool, the drawback with any tool is that uh, it does not give you a one-stop solution for your task, whereas Fabric does provide that. So it gives you one-stop solution to store your data. It gives you one-stop solution to use that data to create charts like Power BI. Okay, it gives you one-stop solution to use that data either for analysis or for modeling. Okay, so that was our agenda of today's session. Okay, to work on finance dataset and create a model on it using our Fabric tool. So guys, what we covered today, was that clear? Swarna says if you use PySpark, with PySpark, Swarna, what will happen is our processing will become more efficient. Okay, with PySpark, it follows Spark architecture, wherein behind the scenes, what happens? It follows master slave architecture, wherein the first your task is submitted to master node, then the master computer or the master node decides that okay, how the task should be split across the slave nodes. Okay. So it through parallel computation, your task will be done more efficiently, but your end result will not change. It's just that your computation will be done more efficiently, but the learning won't change. Okay, irrespective of whether I follow a master slave architecture to do computation or I use a simple compute to do computation, my end accuracy is not going to change. It's just that with bigger data sets, it's better to use PySpark because you would want your computation to be more efficient. That's all. Nothing else. Okay. Santi Prakashas, can we see the decision tree created? There are certain libraries that will help you to print, but over here in our scenario, the decision tree would be very big to print. But yes, there are certain libraries. Okay. I don't remember the names of those libraries here, but in order to print this entries, there are other libraries that we can use. Okay, so yes, you can print your dysentery. That feature is available. Is that your doubt, buddy? If there is any other doubt, you can ask.
At least, can we get why for the particular test case which we had used, why it has given the value, whatever the system has given, like say 0 or 1, on what basis it has done?
For that, what you will have to see is you will have to see that how that entire decision tree is structured. Okay, and as I mentioned, there are certain libraries that you can use to print out your dysentery. Okay, now again, here in dysentery, you have um, a concept wherein it can show you that okay, based on which conditions it has made the decision. But again, it's better to print out the decision tree and see. So for your particular scenario, the scenario that you want to achieve, Santi Prakash, the better way will be to print out the decision tree. Okay,
Okay.
fine, perfect. But apart from that, Santi Prakash, was it clear whatever we learned over here? Was it understandable? I hope.
Yeah, yeah.
Yes, okay. Swarna says in Fabric trial licenses will be, yes, absolutely, Swarna. In fact, my license is also a trial license. So absolutely, we'll be able to use all the features of Fabric. Okay, we'll conduct one more webinar or Fabric, okay, wherein we'll focus on just the Fabric related features. Okay, so we do have webinars almost every week. So please reach out to the technical team, the backend team, and they will guide you that on which week we have which webinar scheduled. Okay, and to learn more about Fabric, we will have more webinars on Fabric as well, through which you can learn. All right, fine. I've already exhausted the time for today. Fine. So, guys, I hope whatever we covered today was understandable. It was something of value to you. We conduct webinars every week. Okay, they are free of cost. You can attend them. You can reach out to the backend team to know more about the webinar schedule. Okay, and they will help you out. Fine. So that's it for today's session, guys. I hope it was understandable. See you in some future session. Till then, bye everyone. Bye, guys. Best of luck.
Thank you.